Good day, my name is Alexander Ventoso and I'm going to discuss three topics on mechanics, which are first, shear stress, the second is torsion stress, and the last is bending moment. However, let's discuss first the topic shear stress. What is shear stress? It's a type of stress that occurs when forces are applied parallel or tangential to a surface. It causes the material to deform by sliding layers over each other. The formula of shear stress. Shear stress equals force applied parallel to surface over area which the force acts. For example, a rectangular beam 100 mm wide and 200 mm deep carries a shear force of 6,000 Newton. Find the average shear stress. For us to get the meter, we have to divide the 100 mm to 1,000. So the result is 0.1 meter. Next one is depth. 200 mm is divided to 1,000. The result is 0.2 meter. So the total area would be 0.02 meter. So now, let's use the formula of shear stress. Shear stress equals force applied parallel to the surface over area which the force acts. So 6,000 over 0.02 is equals to 300,000 pascals. For us to get the final answer, we have to divide the total pascals to 1 million, which 300,000 divided 1 million is equal to 0.3 megapascals. The next one would be torsion. It's a type of mechanical stress that occurs when a structural or machine element is twisted by applied torque, like rotational force. It primarily affects circular shafts like axles, rods, and drive shafts. In addition, torsion is the twisting of an object due to applied torque. It occurs in circular components like shaft, rods, and axles, so it causes shear stress over cross-section of the material. The formula of torsion is torsional stress equals to torque applied times radius of a shaft over polar moment of inertia. For example, a solid steel shaft with a diameter of 60 mm is subjected to torque of 500 Nm. Calculate the torsional shear stress of the outer surface. So first, convert the diameter to meters. 60 millimeter divided by 1,000 is equals to 0.06 meter. So the second is find the radius. So radius equals diameter over 2 is equals to 0.03 meter. So the third step is calculate the polar moment of inertia. So torsional shear stress equals to pi diameter to the power 4 over 32 equals pi times 0.06 to the power 4 over 32 is equals to 6.36 times 10 to the power negative 8 meter to the power 4. Step 4. Apply torsion formula. So torsional shear stress equals to torque applied times radius over polar moment of inertia. So 500 times 0.03 over 6.36 times 10 to the power of negative 8. The result is 235,849,056 pascals. And for us to get the final answer, we have to divide it to 1 million. So the total answer would be 235.85 megapascals. The last topic would be bending moment. It occurs when external forces causes a beam or structural element to curve or deflect. It produces tensile stress on one side and compressive stress on the opposite side of the material. Common in beams, bridges, and cantilever structures. The axis about which bending occurs is known as the neutral axis. Formula: bending stress equals bending moment over section modulus. Example: a cantilever beam of length of 2 meter carries a point load of 1,000 Newton at its spray end. The cross-section of the beam is rectangular, with width of 40 mm and height of 80 mm. Find the maximum bending stress. So the first step is calculate the maximum bending stress. So bending moment equals to force times length. So 1,000 Newton times 2 meter is equals to 2,000 Newton meter. So the step 2 is convert the dimension to meters. So width of the beam is 40 mm. So 40 millimeter is divided to 1,000 is equals to 0.04 meter. So the height of the beam is 80 millimeter is divided by to 1,000 is equals to 0.08 meter. Step 3, calculate section modulus. So 60.04 times 0.08 squared over 6 is equals to 60.04 times 0.0064 over 6 is equals to 60 times 00256 over 6 is equals to 4.27 times 10 to the power of negative 5 meter to the power of 3. Step 4, calculate bending stress. Bending stress equals bending moment over section modulus. So 2000 over 4.27 times 10 to the power of negative 5 is equals to 46.84 times 10 to the power of 6 pascals is equals to 46.84 megapascals. So the maximum bending stress is 46.84 megapascals. That's all. Thank you for listening, and I hope you learned something from the discussions.